All right, hi guys. This is the walkthrough for the right triangle variety. Again, if you have two sides of right triangle and are trying to find the third side, you use the Pythagorean theorem. If you have one side and one angle, you can use the trig functions to find a second side. If you have two sides and are looking for an angle, then you're going to use the inverse trig functions. So we have all those at our disposal here, and that's what we want to try and practice. All right. Question one is kind of a review. You're just simply writing the ratios. So, for example, if we look at D here, right, the 5 is the hypotenuse. Across from D is 3, so that's opposite. And then adjacent would be the 4. And then we can write our ratios. So sine of D would be opposite over hypotenuse. That's 3 over 5. Cosine of D, cosine, right? So katoa. Okay, so katoa. So cosine is adjacent over hypotenuse. So adjacent's 4, hypotenuse is 5. So that's 4 over 5. And then tangent is the toa. So tangent is opposite over adjacent. So opposite is 3, adjacent is 4. That's going to be 3 over 4. Okay. All right, and then for the cosine, sine, and tangent of G, we're going to switch. Right, so we're not going to be looking at angle D anymore. We're going to be looking at angle G. Okay. Cross is opposite, so the 4 now becomes opposite because it's across from the angle we're looking at. Next to is adjacent, so then the 3 is the one that's next to G. So this is going to be adjacent. Okay, and then we would fill in our ratios here. Okay, so that's number 1. Okay, 2 through 7 here, we want to find the missing side or angle that's indicated. Okay, so here we're looking for an angle. So if you're looking for an angle, you're using the inverse trig functions, right? The Pythagorean theorem is used if you have two sides and you want to find a third side. Trig functions are used if you have one angle on one side and you're looking for a second side. Since we're looking for an angle measure, we're going to use inverse trig. Okay. Now we need to figure out which inverse trig function we're going to use. Right. We do want to end up using SOHCAHTOA. Okay, but first thing we should do is label our hypotenuse. So this is our hypotenuse. There's nothing over here though, so we're not using that. Okay, opposite is across, so the 13 is opposite. And next to is adjacent, so the 16 is adjacent. So the ones we have information on are opposite and adjacent. So that's O and A. So that's the part of the TOA, so we're going to use tangent. And again, since we're doing inverse, or since we're solving for an angle, we're going to use the inverse tangent. So inverse tangent. Okay. And then your ratio is opposite over adjacent, so that's 13 over 16. Okay, and then that's going to equal our angle x. Right? So then we would put that in our calculator. Okay. Right, we go over to our calculator. We have inverse tangent. And then our ratio is 13 over 16. Okay, so that's going to give us 39 point. Let's do tens place, so 39.1. degrees. Okay. Number 3 here. First thing we should do, right, is figure out which one we're going to use. So we have one angle and one side, and we're solving for a second side. So if we have one angle and one side and we're solving for a second side, that's one of the trig functions. So the first thing we should do for a trig function is label the hypotenuse and then circle the angle. Next to is adjacent, so the x is adjacent. Okay, across is opposite, so the 20 is opposite. All right. So we don't have any information on the hypotenuse, but we do have opposite and adjacent. So again, that's tangent. And we're going to use regular tangent because we're solving for a side. Here we were solving for an angle, so we used inverse tangent. Here we're solving for a side, so we're going to use regular tangent. So this is going to be tangent of 40 equals opposite over adjacent. That's going to be 20 over x. Okay, we can multiply both sides by x. So we get x times tangent 40 equals 20. And then we can divide both sides by tangent 40. Okay, and we're left with x equals 20 divided by tangent 40. Okay, and that's going to give us 23.8. Okay, so the length of that side is 23.8. Okay, and that makes sense because if this angle is 40, this one's 50. So this angle is a little bit bigger than the 50 is a little bit bigger than 40. So that means that this side is going to be a little bit bigger than the 20. So that one makes sense. Okay. All right, and then let's look at number 4 here. Okay, we got to first figure out, are we using Pythagorean theorem, trig, or inverse trig? Well, we have two sides, and we're looking for a third side. So whenever we have two sides and we're looking for a third side, that's going to be the Pythagorean theorem. Okay, next we have to figure out what our legs are and which are our hypotenuse. So the legs are next to the right angle, so x and 3.6 are your legs. Across from the right angle is your hypotenuse. So 7.4 is the hypotenuse. So it's x squared plus 3.6 squared equals 7.4 squared. Okay. And then you just have to put that in the calculator and solve, right? So we would do 3.6 squared. 3.6 times 3.6 is 12.96. So you have x squared plus 12.96 equals 7.4 squared. So 7.4 times 7.4, 54.76. Subtract 12.96 from both sides. That gives us 41.8. So x squared equals 41.8. To get rid of the square, you take the square root. So we square both sides. It should be plus or minus, but we're doing with length, so we only want the positive. So square root of 41.8. That's going to give us 6.5. Okay, so x is going to be 6.5. And again, that makes sense. That side's a little longer and it's smaller than the hypotenuse. All right, 5. Again, first question you want to ask yourself, are you solving for a side or an angle? If you're solving for an angle, which we are, you got to use inverse trig. So you're going to need to go through the process to figure out which inverse trig function you're going to use, and then what the ratio that you're going to input into that function is. 6, again, first question you ask yourself, are you solving for a side or an angle? Here we're solving for a side. That means we're using the Pythagorean theorem or the regular trig functions. Okay, if we had two sides and we're solving for a third side, that would be the Pythagorean theorem. We don't have that. We only have one side. So here we're going to use regular trig. We have one angle and one side. And so we're going to use regular trig functions to figure out the second side. So you need to figure out which trig function you're going to use and what your equation is, and solve for x. Okay, number 7. They're giving you two sides and you need to find the third side. So that's Pythagorean theorem. A squared plus b squared equals c squared. Okay, your legs are next to the right angle and your hypotenuse is across. Okay, and then you got 6 more, and these questions are all the same, at least the same idea here. You want to find the missing angles and sides, all the missing angles and all the missing sides. So we can do a couple of them, I guess. We'll do 2 of them, and then you guys will have the other 4 to complete. All right. So first thing I'm going to do is I'm going to do the sides. Okay, I'm going to put an X here and a Y here. Okay. Well, you know what? Let's just put an X. Okay. So let's label the hypotenuse. This is the X we made. Okay, here's the angle we have, 62. And then 22.6 is across. So that'll be opposite. Okay, so if we're using our SOHCAHTOA, okay, we're going to use sine because it's opposite in hypotenuse. So sine of 62 opposite over hypotenuse. So opposite is 22.6. Hypotenuse is x. Okay, and then we simply solve for x. You multiply x on both sides, right? And you get x sine 62 equals 22.6. Okay, and then you can divide both sides by sine 62, right? Divided by sine 62. So you get x equals 22.6 divided by sine 62. It's going to give you 25.6. So x is going to be 25.6. Okay. Okay. I'm going to then label this side y. Okay. You have two sides of a right triangle and you want to find the third. You can certainly use the Pythagorean theorem. 22.6 squared plus y squared is going to be equal to 25.6. That's a perfectly valid way to do it. I think it's easier to use the trig though. So I'm going to use the trig here. So what I want to do is use, you have the hypotenuse. Okay. The y is going to then be adjacent. Okay. And so now I'm going to do the cosine, right? Cosine is adjacent over hypotenuse. So we're going to have the cosine of 62, okay, is equal to adjacent over hypotenuse. So that's y divided by 25.6. You could have also done the tangent of 62 equals 22.6 over y. That would have worked as well. Okay, so you could have done cosine, tangent, or you could have done the Pythagorean theorem. All right, to get y by itself, we need to multiply both sides by 25.6. Okay, so we get 25.6 times the cosine of 62 equals y. Whoops, didn't write cosine. Times cosine 62 equals y. Okay, and then we can put that in our calculator. So 25.6 times cosine 62, and that's going to be 12.0. So 12.0 equals y. Okay, so this side here is 12.0. Okay, and then the last thing is we need to find the measure of angle A. Since we have all the sides, we could use inverse sine, right? We could do the inverse sine of opposite over hypotenuse. So inverse sine of 12 divided by 25.6. We could do the inverse cosine of adjacent over hypotenuse. So inverse cosine of 22.6 over 25.6. Or we could do inverse tangent of 12.0 divided by 22.6, opposite over adjacent. Okay, all those would work, but the easiest way is to use the triangle sum theorem. The three angles of a triangle add up to 180. So all we have to do here is 180, okay, minus 90 minus 62 is going to give us 28. Okay, So this angle here is 28. So now we have the three angles of the triangle and we have the three sides. So we're good there. We're done at that one. Okay. Then you got 9, 10, 11. Let's do 12. Okay. All right. And again, all six are the same. So we'll just do number 8 and number 12. And then you guys can do the next four, the other four on your own. Okay. So first thing we want to do is let's just find one of the sides. So I'm going to try and find this side first. Okay. To do that, we're going to label our sides. There's hypotenuse. Right across is hypotenuse. We circle our angle. Across is opposite. Next to is adjacent. So x is opposite. 29.3 is adjacent. Okay, if you use SOHCAHTOA, opposite and adjacent is TOA, so that's going to be tangent. So tangent of the angle, tangent of 28, it's going to equal opposite over adjacent, so x over 29.3. Okay, and then multiply both sides by 29.3, so we get 29.3 times tangent 28. It's going to equal x. So 29.3 times tangent 28, make sure in degrees, 15.6. So x is going to be 15 points, approximately 15.6. Okay, so we can fill that in. Okay, and then I want to then find the hypotenuse, so I'm going to call that y. Okay, so now we have adjacent and hypotenuse. That's going to be cosine. Okay, so we can do the cosine. My hand's hurting from all this writing. Cosine of 28. Okay, equals adjacent over hypotenuse. So that's 29.3 over y. Multiply both sides by y. Okay, and you're left with y times cosine 28 equals 29.3. Okay, we can divide both sides by cosine 28. So 29.3 divided by cosine 28. It's going to give us 33.2. So y is going to equal approximately 33.2. Okay, and that's your hypotenuse, 33.2. Okay, then we could use the inverse trig functions to find the third angle, or we can just use the triangle sum theorem. The three angles of a triangle add up to 180. So 180 minus 90 minus 28, that's going to be 62. Okay, so our missing angle here is 62. Okay, and then we have all three angles of our triangle and all three sides, so we're done. Okay, so this was our second worksheet for the week. So again, we'll do the big blue button meetings, every weekday here at from 4 to 6, and then also upon request for other times, you can email me or text me questions on Remind. But we should all be able to complete this.